Hello and welcome to the Basic Tools of Finance. I'm so excited. I hope you are too. Okay, so we're going to start our conversations about finance, and I've included some extra material if you want to continue the discussion and kind of look at some other things that are above and beyond the learning objectives. My master's degree is in finance, so I always get kind of excited when we get to this particular chapter. So let's go ahead and jump in our first learning objective. Some sub-objectives we're going to look at here is we're going to compute the present value, the future value, and also to compute the present value and future value of annuity and an annuity due. The annuity and annuity due you will not be responsible for, nor will it be on the test or anything like that. I will not talk about it here, but I did provide you with a link from our site so that if you are interested in the, if you make a payment, how to calculate exactly how much you're going to be paying on that car or that house, you could double check their figures and really know, or perhaps you don't really want to know how much you're going to be paying for those kinds of things, then you could do that. Okay, so let's go ahead and get started. Just kind of summarizes some of the learning objectives we're going to look at in this section, in this particular module. So we're going to look at present value and future value. One of the things I want to make clear is we always want to, given the opportunity, we always want to bring everything back to today. Today is known, and so that's why we always bring everything back to today. If you're sitting there trying to figure out, well, which formula do I use? You always want to use the present value formula. And then we'll take a look at some different times when we would use that. In the upcoming learning objectives, we'll take a look at risk, and we'll also take a look at asset valuation. Okay, so we're talking about the financial system, and again, the idea of the financial system is we're going to take savings from the private saving, public saving, and again, remembering that that's usually negative, so this is private savings, and we're going to turn that back out into the economy in the form of investment. And so when we do this, we really make decisions regarding our allocation of resources. And we want to get the most out of those resources, and we want to talk about ways of handling risk, both in a business and in the larger context of our economy. And so finance individuals and people in the finance field really make decisions about how to avoid risk and what's the best ways to make sure that our money is making money, keeping pace with inflation and some of the things that we've talked about already in our course. Okay, the first thing we want to do is we always want to make sure that our money is making money, okay? And so we're going to use the idea of the present value. And if you've ever calculated interest, which hopefully you have in some classes, then you have worked with this concept. So I'm just going to minimize the slide just a little bit. And here's an example. So if you deposit, say, $100 into an account, so that's your principal, okay? And let's say that you're earning 5%. That would be your rate. And we're just going to use one compounding period here. And so let's just say that we're compounding once a year. Normally we compound more than that. So we use one time period. So this would be our N. Our rate is going to be our I, and our principal is going to be our, if I remember on financial calculators, I think it ends up being our P, if I remember right. And so we would say principal times rate times time. So we would end up then, our interest would be 5% times the 100 times 1. So 100 times 0.05 times 1, and that would give us $5 interest that we would have earned on our principal. So at the end of 1 year, we would have $105, the original $100 that we put into the account with the $5 of interest. So that's how much we would have at the end of the year. So imagine doing this for 50 years or 100 years. So that would be kind of tedious to do this over and over and over and over again. So we need a quicker way to get to the how much is the present value of things. The future value would be how much would I get at the end of these time periods. So we're going to also kind of talk about that as well, and I'm going to give you formulas for both. So let's go ahead and advance our slide to the next one and kind of talk about these two concepts a little bit. Okay, so this side just kind of illustrates the idea. If you deposit $100 in the bank at 5%, sorry, it's the same example, I didn't mean for that to happen, but what is the future value of this amount? So there's a really nice little formula that we can use right here, that the future value is going to be equal to whatever our current value is, the present value, times 1 plus the interest rate to a given n. Okay? So here, we used to do this with tables and all kinds of things, but this gives us a really quick way to look at what is the future value of an investment. So we could easily go out 25 years if we wanted to. We could say, okay, the future value of this $100, let's do 25 years because it's not on our example. So we could say, okay, if I invest $100 at 1 plus 0.05 to the 25th power. If you have a y to the x key, you could easily use that on a calculator. So the first thing you want to do is you want to do 1.05, hit your y to the x key, 25, or your exponent key, which would give us 3.39, and then multiply that by the 100, and at the end of 25 years we would have $338.64. So that would be the future value of $100 invested at 5% in 25 years. Okay? So that's a kind of down and dirty, easy way to figure out the future value of something. Now, the present value formula is kind of the reciprocal of this. So what we're going to do for the present value is we're going to say the present value is equal to the future value over is 1 plus the interest rate to the negative nth power. Or another way to look at it, and we'll see that in the next slide, is just the future value over 1 plus the interest rate. And so let's go ahead and look at that on the next slide. So here it kind of gives you the idea of placing the future value over this present value idea. So we can take the inverse again, so we can just say basically we can either use the present value is equal to the future value times 1 plus the interest rate. I used I, they're using R, which is fine. R to the negative nth, or you can just say the future value over 1 plus the interest rate to the nth power. Either one will work and it will be fine on a test. Okay, so suppose that the interest rate is 6%. Okay, should General Motors spend $100 or $100 million to build a factory that will yield $200 million in 10 years? Before we get down to the solution, let's just ask ourselves a couple of questions. And the first question I want you to ask yourself is, would General Motors be saving or investing? Well, if you look at the slide, it tells you pretty clearly this is an investment decision. But if you remember going back to our conversation, if they're building a factory, there's our physical asset. So this would definitely be an investment decision. So let's go ahead and work it out without looking at the solution and make sure that we can get to what the solution would be. So the first part, should General Motors spend that $100 million to buy a factory that will yield $200 million in 10 years? So how we would set this up in a finance kind of scheme is we would say, okay, today we're at time period 0. In 10 years, this will be worth $200 million. We're looking at 6% as an interest rate. Okay. And we're going to spend $100 million. Now remember what I said a few minutes ago. We want to bring $200 million back to today. That's the best way to do this because today is known. A lot of students want to propel the $100 million into the future. We don't want to do that because we don't know what's going to happen tomorrow. So the best formula to use here is the present value formula. So we're going to say, whichever one you want to use, I'm going to use the present value is equal to the future value times 1 plus the interest rate to the negative nth power. Filling this in, I'm going to say the future value is 200 million. 1 plus the interest rate of 0.06 to the negative 10th power. When I do that, I end up with 1.06. I'm going to go ahead and hit my y to the x key, put in 10, and then I'm going to hit my plus minus key. And that gives me 0.56. And I'm going to multiply that then by the 200, and I end up with a present value of 111.68. And so the question becomes, which is larger, 100 million or 111.68? Well, 111 is larger than 100 million, so I would definitely spend the 100 million to get 200 million in the future. So I'm evaluating which is larger. If once you do the calculations, your present value is larger, then you're going to go ahead and do that investment. If it were lower, then you would not. Just hopefully that makes sense to you. But again, you're evaluating, should I do this? Which is bigger? Which would you rather have, 111 or 100? Well, if you'd rather have then 111, then you say, yes, I'm going to definitely build that factory. Let's take a look at what happens if the interest rate changes. Here, the interest rate's going to go up. So again, try not to look at the solution here. I'm going to go ahead and minimize this. And we're going to do the same thing, kind of looking at it in the same way. And again, which is going to be more known. So we're going to spend $100 million today, time period 0. And then in 10 years, I'm going to receive 200 million. Again, I'm going to bring the 200 million back to today because today is known. But now my interest rate is 9%. So I'm going to use the present value formula. This time I'll use the one that your book uses. So I'm going to take 200 million. I'm going to say the present value is equal to the future value over 1 plus the interest rate to the nth power. So I'm going to say that 200 million over 1 plus 0.09 to the 10th power. So when I take 1.09 and I'm going to hit the y to the x key, 10th power, that gives me 2.37. And then I'm going to put in 200 and I'm going to divide that by my 2.37. And I end up with a present value of 84.39. Well, which would I rather have, 84.39 or 100 million? I'd rather have the 100 million. So no, I'm not going to build the factory. I'd much rather keep my 100 million than to spend it on a factory and only get a rate of return of 84 million. So one of the things that take away from here is that as the interest rate increases, the present value decreases. As the interest rate increases, the future value increases. So those are some things to kind of keep in mind as we're evaluating the present value and future value scenarios. Okay, you're thinking of buying a 6-acre lot for $70,000. The lot will be worth $100,000 in 5 years. Should you buy the lot at 5%? And should you buy it at 10%? So if you want, you go ahead and pause this and work it out. And then I'm going to minimize this, and you can go ahead and check your answers. So let's go ahead and work this problem. So I'm going to go ahead and minimize that. Okay, so again, which do we do? Present value or future value? Yeah, we're going to do the present value. So you're going to buy this for $70,000 today. That's how much it's worth today. So that's time period 0. We're going to first look at this at 5%. And it'll be worth 5 years from now. It's going to be worth $100,000. So we want to bring that $100,000 back to today and evaluate what this will be worth today. So what's the actual value today at 5%? So again, I'm going to use the first formula. I'm going to say, okay, the present value, the present value is equal to the future value over, future value 1 plus the interest rate to the negative nth power. Filling that in, we have 100,000. 1.05 to the negative fifth power. So 1.05, hitting the y to the x key, pressing 5, using my plus minus key, and that gives me 0.78. Multiplying that by the 100,000, that gives me 78,000. $352 and roughly 62 cents. Well, which would I rather have? I would rather have $78,352.62. So yes, I would definitely do A. As far as B is concerned, now I'm going to do the same thing. I'll use the opposite formula just for illustrative purposes. Again, I'm at time period 0. That's today. So now I'm going to put in 10% as my interest rate. I'm going to say it's worth $70,000 today. It's still going to be worth $100,000 in the future. Now thinking ahead, what do you think the present value is going to do? It's probably going to go down, right? Because our interest rate went up. So let's just double check that. And so I'm going to bring this back to today. I'm going to say my present value is equal to my future value over 1 plus the interest rate to the nth power. When I do that, I end up with 100,000 over 1.10 to the fifth power. So I end up 1.10 y to the x, 5, gives me 1.61. And I take 100,000, divide that by the 1.61, and I end up with 62,092.13. Which would I rather have? 70,000, definitely, as opposed to 62,000. So B is no, I would definitely not do that. Let's go ahead and double check our answers. And yes, we would buy it in A, and no, we would not buy it in B. So that's exactly what we had come up with. So that's good. So this really just shows us compounding. And compounding is a little bit different. And again, compounding, normally we compound either quarterly, sometimes daily, and this is where we talk about the idea of an annual percentage rate, which is not really annual at all. It can be daily. And so what happens is when we talk about interest rates, we're compounding on interest. So the buy and hold strategy that we tend to see and advise people to use in terms of stocks and bonds becomes pretty important. So if we have a rate of return of 8%, then the future value is different than if we have a rate of return of 10%. Notice the huge difference that we see due to compounding. Okay, the big differences over time. So this is where we many times as financial analysts or as financial advisors, we would recommend a buy and hold strategy as opposed to a churn and earn strategy. Okay, the last little down and dirty method I want to show you works for anything. It can be height of a child, it could be population growth, it could be many different things. But the rule of 70 says that any variable, it could be a stock, it could be the population, anything, grows at about X% per year. And it'll double in about 70 years. So, for example, if our population growth has been 10%, then if we take 70 and we divide it by our population growth of 10%, then our population will double in about 7 years. And it's kind of interesting to look at that. Here's some other examples. If the interest rate is 5%, then your deposit's going to double in about 14 years. Interest rate 7%, double in about 10 years. So it's pretty accurate. You know, it's decimal places off. But we can use this rule to kind of come up with an estimation of how quickly something will double. So if you're looking at something doubling, using the rule of 70 comes up pretty, it comes in pretty handy sometimes to double check things. Okay, thank you very much, and I look forward to seeing you in Learning Objective 2. Thanks.